Hello and welcome to our next lesson on this metals and non-metals topic. Over the previous two lessons we've looked at the reactivity series and we've looked at how we can displace metals from a compound. Today we're going to look at how this displacement reaction can be used in a real world setting. Now today's title, Extracting Metals. I would like you to write in your books please. This as a title as you would do for any other lesson. By the end of the lesson you should be able to recall what an ore is, you should be able to explain two methods of extracting metals, and you should be able to evaluate extraction methods for a metal based on its reactivity. So let's start with a key term, natural resource. Natural resources. Now, everything we have around us comes from the earth. Absolutely everything that we use originates from the earth. And we call these natural resources. So we can define this as materials from the earth its atmosphere and the oceans which can be used as raw materials for products. So we've said that natural resources are materials from the earth, its atmosphere, and the oceans which can be used as raw materials for products. Now an example of this would be metals. Metals are natural resources that come from the earth. Okay, so e.g. metals. But the problem is some metals, such as gold, are found on their own in the earth. They're not bound to anything else. We can just dig up a lump of gold. However, other metals are found as compounds. Okay? So we can say, and I'm going to put in regs, it's important, some metals, such as gold, are found on their own in the earth, are found on their own in the earth ready to be used. So we find some metals or some resources, such as gold, which are ready to be used. Other metals, such as copper or iron, are found as compounds in the earth. Okay? So other metals are found as compounds that need to be separated before they can be used. Before they can be used. And we can say, e.g., copper. Okay, so before we move on, we've got a couple more keywords. Our next one is the word mineral. Mineral. Now, a mineral is defined as a naturally occurring metal or its compounds. So, a naturally occurring metal and their compounds. Okay, so that's mineral, M-E-M-I-N-E-R-A-L. So that's mineral. The next key word is the word ore, O-R-E. Okay, now an ore is a naturally occurring rock, a naturally occurring rock that contains enough of a mineral, that contains enough of a mineral and what we mean by a mineral, we mean a metal, to make it worth mining. To make it worth mining. Now, once we've mined this metal, we can remove the metal from it. Okay? So we can add underneath here that metals found in ores need to be processed or extracted, which means removed from the compound to make them useful. So it says we've got natural resources are materials from the earth, its atmosphere and the oceans, which can be used as raw materials for products, and examples of natural resources include metals. Some metals, such as gold, are found on their own in the earth, ready to be used, while other metals are found as compounds that need to be separated before they can be used, such as copper or iron. Both types are known as a mineral, M-I-N-E-R-A-L, which is a naturally occurring metal and its compounds. An ore is a naturally occurring rock that contains enough of a mineral or enough of a metal to make it worth mining. Metals found in ores need to be extracted, which we mean removed, from the compound to make them useful. Okay? So, if we refresh our screen, we can write ourselves an example of this and we can talk about how it's done. So the example we're going to use is iron, okay? So we can say that iron is found in an ore, as part of the compound iron oxide. As part of the compound iron oxide. Okay? There's two main ways to separate the ion from the compound. So we can then say that ion is separated from iron oxide in two stages, ... We've got the first one where we separate the iron oxide from the other compounds. So number one, we separate iron oxide from the ore, and the second step we've got is that we use chemical reactions, or we use displacement to get the iron from iron oxide. So we use displacement reactions to get iron from iron oxide. Now, if you think back to our displacement reactions, we can react iron with a less reactive element to displace it from its compound. So we can say, just to refresh our memory, I'll put it in red, we can say we can react iron oxide with a less reactive element, and then we can put a comma, in this case carbon, in this case carbon, to separate it into iron alone. To separate it into iron alone. ... And we're going to do some word equations to show this. So we can have carbon on its own. We'll use this one. In fact, no, we won't. We'll use this one. We've got carbon, and we're going to react carbon with iron oxide. Iron oxide. Now remember, this is our element. This is a compound because it's got two words in the name. So this is the element. This is a compound. Carbon is more reactive than iron, as shown in the reactivity series that we've got on the PowerPoint here. Carbon's more reactive than iron. Therefore, the carbon is going to replace the iron in the iron oxide. So instead of having carbon and iron oxide, this time, once we react it together, we're going to have iron, which becomes an element on its own. An element on its own. And that's going to be made due to the production of carbon dioxide. Carbon dioxide, which is now our compound. And we can say, just to refresh our memories, that carbon is more reactive than iron, so displaces the iron from iron oxide. Okay, if we wanted to show this as a simple equation, we could have our carbon. It will produce CO2, so it saves me writing the words out again. We've got FeO, which shows iron oxide. We've got our iron on its own. We can add in our arrows, and this is just sort of a shorthand way of showing it. So we've got carbon plus iron oxide being turned into iron and carbon dioxide, CO2. To balance this, you may have done this, you may have not, I don't know. We need to put a 2 in front of the FeO and a 2 in front of the iron. Okay? Now, more reactive elements cannot be replaced by carbon. This is our final part before I'll give you some questions to do. We can say that more reactive metals cannot be displaced by carbon, comma, instead electrolysis is used. And that brings us to our final keyword of the lesson, electrolysis. Electrolysis can be defined as the use, electrolysis is ALECTROLYSIS. We can define it as the use of electricity to split a compound into elements. We can say underneath here, e.g., aluminium oxide needs electrolysis to extract aluminium, and finally we can say some bad points of electrolysis. We can say that it is very expensive. We can say that it needs lots of electricity. And finally, we can say lots of heat is generated. Lots of heat is generated. So, if we have a look back at our learning objectives, You should now be able to tell me where an ore is, you should be able to tell me 2 methods of extracting metals, and you should be able to evaluate which method you would use based on how reactive a metal is. So what I would like you to do, please, I would like you to pause the video now. I would like you to have a go at the questions on the screen, write out the question before answering it. Once you've had a go at all the questions, get a different coloured pen to hand, press play, and we will go over the answers. So pause the video now, please, and have a go at that. So, you should have had a go at these questions. Let's go over the answers. Reset our screen back to black. Paste our first set of questions. So, for the first one, you needed to leave in the correct word, removing the incorrect one. So I will go over it. An ore is a rock that is worth extracting metal from. Most metals exist in the Earth's crust as compounds. These are mixed with other substances in ores. So question 1 should have read, an ore is a rock that is worth extracting metal from. Most metals exist in the Earth's crust as compounds. These are mixed with other substances in ores. Question 2. Use the reactivity series to suggest whether magnesium is extracted from its minerals by heating with carbon or electrolysis. Explain your answer. So for number 2, 2 marks. For 1 mark, you should have said electrolysis. Electrolysis. And for your second mark, you needed to say, because magnesium is above carbon in the reactivity series. So magnesium is above carbon in the reactivity series. Let's have a look at questions 3, 4 and 5. Paste them over here. Make them a bit small. In fact, I might just put them next to these ones, but we don't need them that big, so I need all the room I can get. So, question 3 says, describe how iron ore is converted into iron, which is useful for making ships and cars. So for number 3, you needed to say that iron oxide is separated from the ore. So iron oxide is separated from the ore for 1 mark. And for your second mark, you needed to say the iron ore is heated with carbon and displacement happens. So iron oxide is heated with carbon or reacted with carbon to separate the iron or to displace the iron. So to displace the iron. Okay. Question 4. Question 4 says, a company has discovered a new source of iron ore. Suggest factors to take into account when deciding whether or not to extract the metal from this ore. So, first one is how much iron oxide is in the ore. It's no good spending a lot of money mining an ore that only contains a small amount of iron. Another one is that if the iron can be extracted from iron oxide, if the iron can be extracted easily from the iron ore, The other one is if it's in a easy location. So is the mining in a easy location? It's no good saying I'm going to mine a load of iron ore if there's houses on top of where you need to dig. That's not a very easy place to get it from, so you need to take this into account. And finally, you need to think of, can you get rid of the waste materials? So is it possible to get rid of waste materials? You could have also had pollution. So is there any people around where there's going to be noise pollution? Is there going to be increased air pollution due to moving of mining materials and whatnot? Final question, number 5. Suggest 2 ways that the waste products from the extraction of iron could be reduced. So you could find ways to use the waste products. So find ways to use the waste. So examples, if you displace iron from iron oxide using carbon, you make lots of carbon dioxide. Can you find a new way to use that carbon dioxide? And you could have also says only extract iron from ores with lots of iron in. So only extract iron from ores with lots of iron to reduce the waste. So hopefully that has made sense. Hopefully you've found that video of some use. If there is anything you don't get or you have any questions, please leave a comment in Google Classrooms or send me an email. I will get back to you as soon as I possibly can. Until then, take care.